Let's take a look at this cylindrical shell method problem. So the revolution axis, I let that be the y-axis. Y-axis is vertical, so therefore the integral is a dx integral. All right, so let's take a look at the graph of the three functions. We have y equals to the cube root of x, which is the orange curve, and then y equals to 0 is the yellow horizontal line, and x equals to 1 is the blue vertical line. When x is equals to 1, you plug in 1 to the curve. Y is equals to 1, easy math. When you deal with a volume problem, keep in mind that x-axis is y equals to 0, y-axis is x equals to 0, right? And then if you use the Washer's method back then, in using Washer's method, this is going to be a dy problem. Since we are using the shell method, we will be using a dx. So for the shell method, what do you have to know? So for the shell method, the volume is equals to x equals to a to x equals to b, lower limit and upper limit, and then you have the circumference multiply the height, and then you multiply the thickness. Okay. And then what is the circumference? The circumference is 2 pi r, right? So that is 2 pi r. And then the height is usually just the function. And then the thickness is either the dy or dx. So how do we interpret this? So imagine that we have a two-dimensional rectangle. So let's draw a rectangle right here. And then what is the circumference? The circumference, so if you roll, so look, you have a rectangle, right? So if you cut this out and then roll up the rectangle, do we agree that we are going to get a cylinder, right? But this piece of paper is two-dimensional. So the 2 pi r, that gives you the base of the rectangle, and then the height is the function. Usually the top curve minus the bottom curve, those kind of thing, right? And then what about the thickness? The thickness is the delta x. So imagine this. We are trying to make some thickness on this. So therefore, this is going to be a two-dimensional rectangle. So just like that, I can draw this real quick for you. So here, so we can make this three-dimensional. So the thickness is really how thick the rectangle is. So do we agree that when we roll this up, we are going to get a shell? So this is three-dimensional. When we roll this up, we are going to get a shell. So the delta x is the thickness of this rectangle. All right, so how do we find the r? How do we find the height? So let's go back to this problem. First thing first, I would like to find the radius. So what is the radius? When you find the radius, I want you to do this for me. How do you find the area? The area is the top curve minus the bottom curve, which is the cube root of x minus 0. So therefore, this is our rectangle right here. You can either draw a line or you draw a rectangle. When I was a student, I just draw a line. I just use a line. Either use a line or use a rectangle. All right, so the radius, how do we find the radius? The radius is not really the top curve minus the bottom curve. So take a look at the spinning symbol, the y-axis. So the radius, so take a look, the radius is the distance between the revolution axis and the rectangle. So how do we measure this distance? So to measure this distance, I will be using x minus 0. What does that mean? What is x? X is any x. Okay, so any x between x equals to 0 and x equals to 1. So between the 0 and 1, because that is the lower limit and upper limit, the area is bounded between x equals to 0 and x equals to 1. So any x between x equals to 0 and x equals to 1 minus the y-axis, or you can say x equals to 0. I mean, not x equals to 0. The y-axis is, yes, is x equals to 0. X equals to 0. So this x equals to 0 is just the y-axis. Do you still remember that the right minus left? So the right minus left, you use a bigger x minus the smaller x. that measures the distance between these two x values. So that is the radius. And then what about the height? So the height, let's do this in another color. So the height right here. How do we measure the height? The height will be how tall is the rectangle. So that will be the top curve minus the bottom curve, right? So that will be the top curve minus the bottom curve. So that is equals to the cube root of x minus 0. So which is y equals to cube root of x minus y equals to 0. So let's make the 3 look better. And now we have all the ingredients to set up the integral. So when you set up the integral, this is what we do. So the volume is equals to integral. So since that is a dx integral, we have x equals to 0, x equals to 1. When you do your homework online, the system might not read the x equals. So just write 0 and 1. And then 2 pi, what's the radius? The radius is x minus 0. And then multiply the height. The height is the cube root of x minus 0, and then the thickness is dx. I suggest you to write out the entire integral like this. The entire integral. Do not simplify this. So even though you want to simplify, you write another line. Because let me tell you this right now. If you don't write the minus 0 here, and you don't show all your work, like how do you get the height, how do you get the radius, when you go back to your notes 2 days from now, you are not going to remember anything. So that's why I highly recommend you to write everything out. I know you are very good at simplifying this. You do that on the next line. All right, so that is how we set up an integral to find the volume using the shell method. I know people ask what if all the time. I am going to do the what if right now. So here is a what if. So let me switch to another color. So let's do a red. So what if I change the revolution axis to here? Just a what if. So what if I spin the area right here? So what is that x value? How about x equals to -5? And then after that, I want to do one more. I want to do a spinning right here. How about x equals to 9? How's that? So here, let me go ahead and cut this picture and then bring it down below, so we don't need to keep going back to the top of the note. So copy, and then I will just bring it right here. All right, so let me just erase the extra stuff. And then now we can keep working. Okay, let's match the color code. So now, first thing first, x is equals to -5. What is the radius? So the radius is now any x in the region subtract x equals to -5. So this is any x in the region minus x equals to -5, because when we do the right minus left, we measure the distance between the x and the revolution axis. And then what about the height? No change, right? So for the height, you still use top minus bottom, which is equals to the cube root of x minus 0. So this is y equals to cube root of x minus y equals to 0. All right, and then the volume is equals to, from 0 to 1, you have 2 pi x minus -5, and then the height is cube root of x minus 0, and then the thickness is dx. So that's how we do this problem. What about the x equals to 9? So for the x equals to 9, so this time the radius is equals to right minus left, 9 minus any x between 0 and 1. So this is x equals to 9 minus any x in the region. And then the height, no change. Is still the cube root of x minus 0. So you have the volume equals to x goes from 0 to 1, 2 pi r and then the cube root of x minus 0, so dx. So that's answer all the what if question. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video for me, share the video for me, subscribe to my channel if you haven't done so. See you all in the next one. Signing off for now.